Good evening, everyone. Welcome in our monthly CoffeeJUG event, live stream event, and also welcome our today's speaker, Ihor. Today, he'll share his experience and knowledge about building blocks of Spring Security. At the same time, complex thing that contains very basic stuff that we should discuss and understand. And Ihor will present insights from these basics. And of course, our monthly CoffeeJUG event, it's about network, it's about sharing knowledge and their experience. So welcome everyone again. And don't forget the general partner of today's event, of course, is Armed Forces of Ukraine. Because of their brave and sacrifice, we have opportunity today to actually organize this event and see and share our knowledge and discuss some interesting stuff from engineering. So thank you. And also don't forget that they defend our country from Russian aggression and from occupation. So don't forget to support Armed Forces of Ukraine in various ways. It doesn't matter, is it volunteering or donations or any other ways, even if it's just sharing news and awareness. Thank you and glory to Ukraine, glory to our heroes. Our community, for the past months, we organized more than 50 events, and today's is 55th event, and there are more than 700 participants, unique participants in our events. So our community is growing, and also special thanks to our organizers team. Behind the scenes, they trying to organize everything and provide the best experience in our events, find speakers, and review their talks. So thank you, guys. So don't forget to connect CoffeeJUG in the social medias and stay tuned to follow our future events and news about the next meetups. Thank you. So next, let's not wait and jump and dive together to Spring Security. Ihor, please go ahead.
Yeah, hi everyone. Thank you for inviting me. I'm glad to be speaking here today. And today I'll be speaking about Spring Security, but not about some fancy setup. I'll be speaking about basics which underpin every Spring Security setup and which will let you be confident in front of any setup and keep your ground with any configuration possibly. So you certainly would need to read documentation if you would go to more diverse setups and so on, but this information, I believe, will let you progress easily through any configuration since this time on with Spring Security. So let's dive right in. About me, I'm working at Avenga. I'm passionate about system architecture and software engineering. Here you can find my contacts. I'll be very happy to accept your connections on LinkedIn. Also, I started writing on Medium, and you can find the series about Spring Security. There are 11 articles overall on Medium, and also the code for this project can be found on my GitHub, and you can follow through the links or scan the QR codes here. So let's start from the agenda, what we'll be covering today. We'll start from the overview of essential elements of any Spring Security authentication mechanism. And then, based on that knowledge, we will set up simple custom authentication mechanism for REST API. We will be leveraging JWT for transferring authentication credentials, and I believe that's a standard authentication for most of the backend applications which expose REST API, I believe, at this point of time. Then we will explore out-of-the-box Spring Security authentication mechanisms, and we will take a look at into their customization points. After that, we will go through the modularization of the Spring Security configurations, and we will see how to make our Spring Security setup modular and how to split it into independent chunks, how Spring Security internally manages their configurations, their out-of-the-box configurations and other configurations that they have as part of their framework. Then we'll go through the setup of authentication mechanism for REST API, supporting different types of authentication. In this example, we will join together JWT token and API key in scope of one authentication mechanism, for different types of clients potentially. And then we will go through a combination of different security setups in one project. And in the end, there will be some recap and recommendations. Let's start from the basic overview of Spring Security main essential elements. I'd say probably its architecture. And let's start first of all from what is Spring Security. It's a framework, which is a part of Spring Framework ecosystem, and it's intended for implementing application level security. And by application level security, it's mainly meant authentication and authorization. Authentication is the process of understanding who the user is for your system, what is users or callers' identity in general. And authorization is a process of understanding whether this action is allowed for the certain caller or not. So basically authorizing the action. And also application level security might include some application level cyber attack protection and so on, which is also included in scope of Spring Security in different forms, such as CSRF protection and so on. And many engineers would agree that Spring Security is one of the most challenging parts of Spring Framework. It's big. There are many different options of setups and many different configurations. That's why sometimes it creates the confusion. But I strongly believe that understanding of the essential cornerstone elements of the Spring Security, what they call basics of Spring Security, will let you be confident in front of any Spring Security setup. So let's dive right in. Spring Security, mainly based on filters. Its authentication and authorization logic mainly operates at this layer. And in case you want to know what is filters, so filters is a part of servlet specification, and Spring Web application, which we will be working with today, is based on servlet. It uses one dispatcher servlet, and servlet is a specification which allows application server to transfer the flow of control to your logic. The application server, such as Tomcat or Jetty, loads your servlet within, and it calls its APIs, passing the flow to your application while handling application web server logic on its side. And before invoking the servlet application container, Tomcat or Jetty or any other, it calls filters, which are applicable to this certain request. So filter is sort of middleware, and even from its name, it can be understood that it's a perfect place to put your authentication and authorization logic. So that's why Spring Security mostly operates at this layer. And let's check what types of filters are there. So there are authentication filters. Their main job is to perform authentication, to understand based on the credentials in the request who this user is. And there are authorization filter, which performs authorization of the request based on the identity of the user, authority of the user. It checks if the user is allowed or not allowed to perform certain action within the system. And there are other filters like attack protection, security session, exception translation, etc. Also, why I say that Spring Security mainly operates at filters layer is because there is also a layer of Spring interceptors, and at Spring interceptors layer, the method security is handled. And method security is whenever you use pre-authorized annotation on top of your methods and you define the expressions to be evaluated as authorization rules, or when you use security annotation or something like that. So mainly, authentication logic remains in the filters, but authorization logic is spread across filters, authorization filter, and Spring interceptors layer, where the method security is evaluated. Also, there is a notion of Spring Security filter chain, and filter chain sort of bundles together all the filters which should be invoked in sequence, one after the other, for a specific security setup. Application might have many security filter chains registered, but only one security filter chain can be applied for securing a specific request. actually first of them which matches this request. And we can specify the matcher for the request which will be matched by the security filter chain while we are configuring the security filter chain. And we will see it more in the details later in this talk. So let's now see how to build a security filter chain. Probably everyone who's touched Spring Security at least somehow have seen this object, HTTP Security. And yeah, HTTP Security is a builder of security filter chain. It creates an instance of default security filter chain, because security filter chain itself is an interface, and default security filter chain is a class implementing it. It's the only implementation which is available in core of Spring Security. You can obviously create this instance just yourself by allocating it via a new keyword and then assembling all the filters inside of that. But that would be hard for you, and that's definitely not something you want to do in the real setup, because it would be hardness to support. That's why Spring Security as a builder was introduced, and it allows us to configure Spring Security by building the appropriate instance of security filter chain. And HTTP Security is registered as a bin in Spring Security, so it can be injected pretty much everywhere where Spring Security supports injecting something, but most of the time you will be injected into bin annotated method of a configuration class, because this bin annotated method should return you a security filter chain, and this security filter chain should be registered as a bin for Spring Security to sort of pick it up. So yeah, let's see how it looks in the code. Yeah, I have my class. I can name it whatever way I want. I put configuration annotation above it. And here I have the method where I'm accepting HTTP security, which is injected by Spring container. I'm putting bin annotation above this method. And here I'm using different methods to configure the security. And at the end, I'm calling .build, which constructs the instance of default security filter chain. And I'm returning this instance here, which will be registered with the container, and then it will be picked up by Spring Security. You can see that methods accept some parameters. Usually, it's one parameter, and this parameter can be used to further configure it. For example, authorize requests receives some parameter, and we can configure like request matchers and so on. And we will also see in details what this parameter is throughout this talk as well. So moving on, that was pretty basic and pretty simple. Going further, now the next element is actually how the data about the request is passed through the filters and through the authentication, authorization parts, and to your business logic in your application. And the cornerstone element here, which I also consider to be a sort of heart of Spring Security, is authentication object. And authentication object has basically two purposes. It can be used to transferring credentials about yet unauthenticated request, and we will call it unauthenticated authentication, or it can be leveraged for transferring credentials of authenticated requests, and I will call it authenticated authentication. Usually inside of the authentication, there is authentication principal, and authentication principal is designed to transfer the data about the current user. The authentication is meant to be wrapped into some tiny wrapper, which is called security context. And security context is stored within the application for the time of either request processing or, depending on the type of your application, might be some sort of session and so on, into the place which is called security context holder. It has different strategies for how the security context is stored within it, but the default strategy is thread local strategy, and it's used as well for Spring Web application, because web application servers such as Tomcat, Jetty, any other, it invokes each separate request in its dedicated thread. Yeah, the threads are obviously reused, but during the duration of the request, the thread is allocated for the specific request. So thread local strategy is used as well. Authentication filters are meant to create authenticated authentication. So the authentication which contains the data about authenticated request and potentially with principal within it, or it's meant to throw authentication exception. And all other parts of Spring Security and other parts of your application, then they can leverage authentication from within your security context holder. So authorization filter will be leveraging your authentication to check what are the authorities within this request and whether the certain action which right now is requested can be performed or not. The same is for method security interceptors. And also within your controllers, you can accept either authentication or authentication principal from within your authentication, or you can use security context holder wherever you want in your application, and you can also fetch authentication from within it. And let's take an overview of authentication interface. So what's inside of that? There is a method isAuthenticated, and this method indicates if this authentication is actually authenticated, if it carries the data about authenticated request, or if it's authenticated, which means it carries the request authentication credentials. Then there is a method setAuthenticated, and it's designed to allow switching between unauthenticated and authenticated states of authentication. You might leverage or might not leverage it. It depends on your implementation. There is a method getPrincipal, and it returns data about authenticated user. It's used for authenticated authentication, and it returns object. So just notice it that it's object, not any other type here. And we will see later why. Also, there is a method getAuthorities, which returns a list of user roles as a collection of granted authorities, and it's also relevant for authenticated authentication. There is a method getCredentials, which is relevant for unauthenticated authentication, and it returns credentials of the current request. Also, there is a method getMain, which is designed to return you username of the current user, and method getDetails, which might return you additional details about the request. So let's go through the simple setup and see how we can leverage all this information to make production ready, but pretty simple setup. So the authentication requirements will be REST API auth with token, so either JWT or opaque token for our application. Yeah. And in case you don't know, opaque token is just a random string with no meaning, but the fact that it's random makes it hard to guess. So if we are issuing it to the user and we are also storing it somehow on the backend side, and when the user makes the request and it includes this string somewhere in the request, potentially in the authorization header, we know who this user is, and we know that potentially this user is who he is because the string is random and it's hard to guess. And also there is a JWT token. It's also a string, but the string contains encoded content, so it can be used to transfer information, and it has a signature. And signature makes it impossible to change without knowing the key. Yeah, is a private key or symmetric key, because the signature will not match in that case. Yeah. So this token can be read by anyone. It can be issued only by the owner of the key. So if you use public-private signature, it's a private key, or it's a symmetric key if you use a symmetric signature algorithm. And it can be verified by the owner of the key. So it can be either public key if you use public-private keys, or symmetric key if you use symmetric signature. Yeah. So let's see what the application would look like. So for the case of opaque token, it would look something like this. So first of all, we have to define some public endpoint, which would do login, obviously. And upon the login, we will generate this random string, which we call opaque token. And we will store this opaque token in some cache together with some data about current user, yeah, sort of session data. I would call it auth user. Then this token is returned to the client, and the client should include this token now in the subsequent request, potentially in the authorization header. We're also defining security authentication filter, and now it's a first part of the Spring Security setup. And the job of this filter will be to retrieve the value of the authorization header, to look up if the auth user is present in the cache, and it can be either internal cache or some centralized cache, Dynamo or DynamoDB, something like that, whatever you want to use. Yeah, the implementation details don't matter that much here, but it should check if this auth user is present by the token. If the user is found, it would create the object of authentication. So it should be authenticated authentication, and it would set it into security context holder. Otherwise, it will throw authentication exception. And then all the other parts of Spring Security within this request will be able to leverage authentication, and also your controllers and everything else also would be possible to leverage this authentication as well. For the GWT case, the step is pretty much the same. The only difference is how you verify the validity of the token. So in this case, you are not checking the token in the cache. You are using verification algorithm for the token. So you basically verify the signature of the token. And it sort of creates stateless authentication mechanism, because all the data about the credentials in the request and the data about current user is sent from the client side, but we can trust this data because the token is signed and it cannot be changed without knowing of the key. And the key is known only by the backend. So upon the login endpoint would be reaching to some class which I just called GWT service, and this class encapsulates the logic of creation and verification of GWT tokens. And upon the login endpoint, the GWT service will be generating the token, and this token will be returned to the client. And on each request processing, security authentication filter will be reaching to this class to verify if this token is valid. And all the rest of the setup remains pretty much the same. So now let's switch to the code and see how it all actually looks in the code. So we start from the authentication object, as I called it, the heart of Spring Security. So I'm creating just a record class here because it's meant to be transferring data only. And I'm implementing authentication interface. Here are all the methods we already have seen. So we have the method getAuthorities, which returns a list of authorities for this authentication. Then the method getCredentials is not needed, because in this example, I'll be using authentication only to transfer data about authenticated requests. So I will be sort of using only authenticated authentication. GetDetails I'm also not using in this example. GetPrincipal returns our auth user. And let's take a look what our auth user object is. So it's a simple record as well, but can be class, whatever you want. And it it's designed to transfer the data about the user, which we actually need. So in my case, I transfer user ID, and I also transfer here a collection of roles. I don't need to implement any interfaces here, so notice it, because the method getPrincipal returns object. Is authenticated, I'm setting to true, because this authentication, as I mentioned, always will be used to transfer data about authenticated request. And set authentication I'm not using, so I just set it to no op. And getName also returns null. So now let's take a look at the filter itself. So here is security authentication filter. I extended it from once per request filter, and if you want to declare your filters as components, you have to extend from this class in order to avoid double invocations. I'm injecting here GWT service, which will be responsible in this case for verifying GWT tokens. And the job of the filter is pretty simple. First of all, it gets the header from the request. So there is some name for the header. By convention, it should be authorization header. Then if the header is not present, I'm simply passing to the next filter in the security filter chain. So eventually, the request processing will reach the dispatcher servlet and will reach the controller method, and I'm simply returning here. Otherwise, if the header is present, I'm stripping the prefix here because it's starting from bearer also by convention. And then I have pure JWT token. I'm using JWT service, my class with pretty much simple logic to verify this token. So I'm just verifying the token here. If this method throws an exception, I'm remapping it to token authentication exception. So I'm catching it, and token authentication exception is a custom exception which extends authentication exception from Spring Security. And then if the token was indeed valid, so this method haven't thrown exception, we have the JWT token from which we have the content of the decoded JWT token from which I'm fetching the user ID, the roles, and I'm creating my object of auth user. So after that, auth user is set into authentication, and here I have new instance of authentication, which we remember will be authenticated because is authenticated always returns true for us. And yeah, then I'm creating empty security context. I'm setting authentication there, and I'm setting this context into security context holder, and I'm simply passing to the next filter. As simple as that. So pretty simple work of this filter. And the only remaining part is to actually create the instance of security filter chain and register it as a bin, so Spring Security will pick it up. So here in my class annotated with configuration annotation, I'm creating the method annotated with bin annotation, which means the Spring Security will be injecting objects here, and also whatever I return from here will be registered to Spring context. I'm accepting HTTP security here, and first of all, I'm registering the filter. When you register the filter, you have to specify either before or after which filter you register it. I'm registering it before authorization filter, which is at the end of the security filter chain, usually at the end of the security filter chain, and which is responsible for actual authorization. Then I'm using method authorize HTTP request to specify authorization rules. Also, I'm disabling CSRF because it's not needed. I'm setting session management to stateless, and I'm customizing exception handling. And for exception handling customization, I've defined two implementations. One will be for access denied handler, which is designed to handle authorization exceptions, which is any exception extending access denied exception. And for authentication entry point, it's authentication exceptions, including the exceptions thrown from our filter, which should extend authentication exception. And those filters, those handlers will be leveraged internally by some filter called exception translation filter. So let's take a look into implementations of those exception handlers. So for application access denied handler, I have to simply create authentication implementation which implements access denied handler. Here I am receiving access denied exception, and it simply specifies the logic of writing the error response based on that. And for authentication exception, pretty much the same. We have to implement authentication entry point. As a parameter, it receives request response and authentication exception. And here's the response logic. The logic of writing the response based on the contents of the exception is written. Yeah, and that's it for this setup. As simple as that, we can create like production-ready implementation, which actually suits most of the cases when we need REST API auth with JWT token. And due to its statelessness, JWT token is most of the time used for backend security, for microservices. And this setup can be leveraged there. One remaining thing which probably makes sense to show as well is login endpoint itself. So it's just a simple service receiving credentials, in my case, username and password. It does fetch the username using some logic in the service. It's pretty much a regular service, just like place to extract out the code related to working with this logic. And then I'm checking if the password is correct, and based on the data about the user, I'm creating the token here. And the logic of creating the token is displayed here. So we just create the GWT, we set our data there, and we sign it using our signing key. And the token is returned just as a part of the DTO to be included in all the subsequent requests by the user. So that was a simple setup. Now moving on. What we've done throughout this setup. We created a custom class to carry data about authenticated user. We called it auth user, and this class is not required to implement any interfaces in this particular setup. Then we did a custom implementation of authentication interface, which we called user authentication. And we created a custom filter, which we called security authentication filter, to fetch the authentication credentials from the GWT token. So actually GWT token from the request. Then we checked authentication rules. In this case, the GWT token validation took place. If the token is not valid, we are throwing instance of authentication exception. And if the token was valid, we are constructing authenticated instance of authentication, user authentication with the principal inside of that. And we wrap authentication into security context, and we set it into security context folder. At the end, we are creating instance of security filter chain via leveraging HTTP security builder. And that's it for this setup. Moving on. So out of the box mechanisms. Spring Security team has created for us a couple of mechanisms for the authentication mechanisms, which are both not that simple to implement and similar between the different projects, with only some subtle difference on how authentication logic itself should be handled. And among such mechanisms are form login, which would register its own filter, username password authentication filter, and it has its own authentication implementation, username password authentication token. Also among them is HTTP basic, which would register basic authentication filter and also would leverage username password authentication token implementation of authentication. And other out-of-the-box authentication mechanisms are available, such as OAuth, SAML, X509, but they require specific dependencies to be added to the project. Obviously, the out-of-the-box mechanisms cannot be used the same for any project. Yeah, you don't want to implement the same authentication mechanism across any project. Yeah, there should be customization points for the things which you do differently in each project. Yeah, and those things are usually the way you perform the authentication rules in your project. Yeah, and there are a couple of customization points for that exposed by HTTP security. First of them is Authentication Manager, and its job is to convert unauthenticated authentication into authenticated one. So it performs authentication rules. It receives unauthenticated authentication, and you remember we were talking about unauthenticated authentication. So the authentication can be used to transfer the authentication credentials of the request. Yeah. And then the job of the authentication manager is to sort of authenticate it, to sort of convert it into authenticated one. And there is another customization point, which is called authentication provider. And it's used in the case when you have potentially different authentication implementations in your project, and you want to have different authentication rules for authenticating them. Because you can have only one authentication manager per the security filter chain. But authentication provider would allow you to have many implementations of authentication logic in scope of your setup, in scope of your security filter chain per each authentication implementation individually. So the job is pretty simple. It converts an authenticated authentication into authenticated one, but you might have many of them. Internally, if you would register authentication provider, the specific implementation of authentication manager would be leveraged, which is provider manager. And you can even deeper leverage out-of-the-box mechanism logic and even less customize it by specifying only how the user will be fetched by its username, if it's used your authentication mechanism, obviously. And to do that, you specify user detail service implementation. Internally, if you specify user detail service, if you register user detail service, the specific implementation of authentication provider, which is the authentication provider, will be registered. And also, obviously, the provider manager implementation of authentication manager will be registered as well. So let's now see a couple of common configurations to have a better sense of how it all works. First of all, let's start from form login. Yeah, as an authentication mechanism and as the customization point, we will be leveraging authentication manager. So we will be providing our own authentication manager implementation. In scope of this setup, if you apply it, there will be specific filter, username password authentication filter registered, and also a couple of other filters as well, but we will focus on username password authentication filter because it delegates to authentication manager. And as an implementation of authentication manager, we will register our own implementation, and this implementation would accept the authentication from Spring Security. It will be username password authentication token because that's the type of authentication, that's the implementation of authentication, which is leveraged by form login. And we will be accepting an authenticated instance, and then we perform our authentication rules and we return authenticated instance. So let's see how it looks in the code. So I have to switch to this branch. And let's take a look to the configuration of security filter chain. So here I'm in the class where I'm configuring security filter chain. I'm invoking method form login, just passing the defaults as a configuration here, and it would enable form login authentication mechanism. And then I'm leveraging method authentication manager to register my own authentication manager implementation. And then there are methods to configure authorization rules and some exception handling as well. So now let's take a look at the implementation of authentication manager. So authentication manager implementation should implement authentication manager interface. It has only one method, which accepts authentication, returns authentication, and can throw authentication exception. It accepts unauthenticated authentication, and it should either throw instance of authentication exception or return authenticated authentication. That's how this contract is defined. And here in the implementation, I'm fetching the username from the authentication, leveraging getName method because this method is defined in a username of password authentication token. Then I'm fetching some data about user from my class, just regular class, just to abstract out the logic of operations related to the user. When I fetched the data about the user, I'm checking if the credentials match. If they don't match, I'm throwing the instance of authentication exception, and that's my custom instance of authentication exception, which extends authentication exception. And after that, I am creating an instance of auth user, and take a look that auth user is not required to implement any interfaces in this setup. And I'm creating a new instance of user password authentication token, which is authenticated. And how do I know that it is authenticated? Well, this specific constructor, which receives a collection of authorities, it says authenticated to true, for example, in contrast to the other constructor. So I use this constructor, which would create authenticated authentication. And well, as simple as that, the authentication manager is implemented, and here in the security config is leveraged. And that's how such a setup can be built. Now let's move to, yeah, there was a slide for showing the code, but okay. Now let's move to the next setup. In this setup, we will also leverage the form login authentication mechanism. But as a customization point, we will leverage authentication provider. So internally, it would cause provider manager implementation of authentication manager to be registered. And it will delegate to our instance of authentication provider. And potentially, it might support any other authentication providers if we register them. So let's move to the code for this example. And here the configuration looks pretty much the same. We are invoking form login to enable form login authentication mechanism. But instead of authentication manager, we are registering authentication provider here. And we might register many of them in scope of this setup. And then all the other setup looks pretty much the same as in the previous project. Now let's take a look at our custom authentication provider. It has to implement authentication provider interface. So interface contains two methods: authenticate method, which receives unauthenticated authentication. It should either throw authentication exception or it should return authenticated authentication, and it also might return null. And then if it returns null, the other authentication provider which supports the same type of authentication will be invoked. So that's something to know. This method can return null, but usually if you don't have the case when you have multiple authentication providers with the same type of authentication supported, then you would want to throw an exception in case you don't want to authenticate this authentication. Returning null basically means that this authentication provider is unsure, and there are potentially others for this type of authentication. Yeah, and the other method is supports. It returns true or false based on the type of the authentication. And that's how the provider manager internally knows which authentication provider to invoke. So moving to the implementation, authenticate method looks pretty much the same as the implementation in authentication manager. And there is additionally method supports in which we are checking if the instance of authentication is username password authentication token. And well, yeah, that's pretty much it for this setup. So moving on. In the next setup, we will leverage user details service as a customization point for the same form login authentication mechanism. And internally, provider manager implementation of authentication manager will be used, as well as the authentication provider of authentication provider will be used. And then we provide our own instance of user details service just to specify how to fetch the user by its username. So now let's move to the code. If we take a look to the configuration looks pretty much the same as in the previous example, except the fact that we are registering not authentication manager and not authentication provider, but user details service. And we are providing our own implementation of it. And the implementation looks the following. We have to implement user details service. It has one method, receives the username, and it should return the instance of user details, which means auth user, which we are returning from this method, has to implement this interface. And in this setup, we are implementing user details within our auth user, and yeah, here are the methods that we have to define. And as an authentication logic, I can write any logic here I want, so I just use my service class to fetch the user by its username. Yeah, and the last example of out-of-the-box authentication mechanisms In this example, we will leverage authentication mechanism, which is called HTTP basic, and customization point will be user detail service, but we will leverage out of the box user detail service implementation. And by default, there are two. There is in-memory user details manager, which works in memory, and there is GWC user details manager, which works with database. It leaves you with the less customization, leaves you with the less flexibility, but anyways, let's see how it works. In some cases, it might be applicable. So let's take a look into our configuration. So here in the method which constructs security filter chain, I'm invoking HTTP basic, which enables HTTP basic authentication mechanism. Then I'm configuring some rules, and I could register username service here, user detail service here. In this case, I would construct new instance of in-memory user details manager, and I would do some setup around it. But there is actually a handy builder method, which is not available on HTTP security, but is available on Authentication Manager Builder. And Authentication Manager Builder is also present in the context because it's registered as a bin by Spring Security. So I can authorize it in my method, and I can leverage its API. So I'm leveraging in-memory authentication method, and which would create in-memory user details manager and register it internally, and then I'm specifying some configuration regarding it. And the interesting fact is when you are using user details service method on HTTP security, it internally delegates to Authentication Manager Builder as well. So just the fact to know. And yeah, that's how we can set up HTTP basic configuration for authentication mechanism and as a customization point, out of the box implementation of user details service. So moving on. Yeah, the next topic is actually very interesting one, and it's related to how the Spring Security setup can be modularized. Yeah, how we can create independent bundles of configuration which are dedicated for setting up specific security mechanism, and how they can be leveraged independently. And I call it how the magic works because it is how internally Spring Security works, and it would help us to understand how actually all those configurations work. So you may ask me, how do I know what is created by out-of-the-box mechanisms? Yeah, because I was telling which filters are created and so on. And well, I just taken a look into their configurers. And the configurers, they provide the modularization of security configuration. They sort of bundle together all the setup of specific authentication mechanism. And for example, when you invoke form login method on HTTP security, internally, if you would check what is happening inside of that method, it actually applies a specific configurer. In this case, it's a form login configurer. And if you would wondered what this thing is, which I was passing inside of the parameters, it's just an empty lambda with one parameter. So as simple as that. But if I'm using it like this, yeah, if I'm creating this lambda, it's easier to see. So that's why in this configuration, I'm setting up some login page. And if you would see what this actually is that I'm passing here, it's passed to the form login method as a parameter. And on this object, the method customize is called. And the parameter of customize object is the configurer. So whenever you configure, for example, form login, inside of your lambda for the customization, you receive the configurer for the further setup of the configuration. So the configurer is applied internally by HTTP security. And also it's passed to the method, so you can invoke additional methods, additional API on that to like configure this mechanism for your need. And that is the case, for example, also with exception handling. So if you invoke exception handling on HTTP security, the parameters that you receive is exception handling configurer, and you can leverage these methods to like set up this configurer in the way you want. And then when Spring Security would apply it internally, it would leverage the setup you've done. And the same is even true for authorized HTTP request method. So the object you're receiving here is not the configurer itself, but the configurer is applied and the registry is fetched from it. And then you register this, you accept this registry to like register your rules on it. Let's see what is the contract of the configurer and yeah, how we can create like own configurer. So HTTP security configurer, they should extend abstract HTTP configurer, and it has two methods. The first one is init. It initializes the builder with shared objects and default settings for the configuration. And the other one is configure. It applies specific rules and settings to the HTTP security. Both of them will receive HTTP security as an object, and the two methods exist basically because the pre-configuration happens before them. Yeah. For example, if you want to register authentication provider and you want to have an instance of provider manager based on the registration of this authentication provider, you would want to register authentication provider in the init method. Then the pre-configuration happens, and based on the registration of authentication provider, the Spring Security will register a specific implementation of authentication manager, which is provider manager. And then in the configure method, you would be able to leverage that. So for example, if I would create the mechanism for GWT security, yeah, for GWT authentication, as a configurer, I have to extend abstract HTTP configurer, and it has a generic. The first type is the type of the configurer itself, and the second type is the type of the builder for security filter chain. And in this case, it's HTTP security. And I have to implement two methods. The first of them would register authentication provider in this case, yeah. And in the second method, I would be able to leverage as a authentication manager from within of the HTTP security. So I use a method get shared object to fetch the object from internal storage of HTTP security, which is called shared objects. And then based on this authentication manager and a couple of other parameters, I'm creating the filter and I'm registering that. So here in two methods, I specify the whole authentication mechanism as a separate modular setup, which can be independently applied. And it can be applied simply leveraging this method. So on HTTP security, I call this method and I specify the instance of my configurer. And the other parameter can be used to further configure it. But here I'm just passing an empty lambda, which is customizer with defaults. Yeah, let's see what are the configurers for out-of-the-box mechanisms. For form login, whenever you invoke form login, the form login configurer will be applied, which will do all the setup related to form login. When you invoke HTTP basic to enable HTTP basic authentication mechanism, there is HTTP basic configurer. And whenever you register user detail service implementation via user detail service, there will be the authentication configurer applied. And obviously, there are many more, as you have seen already. Now, an important point is that you probably have seen in the first setup that logic of security filter, yeah, when we were setting up the security for REST API, would be pretty much simple for every project, pretty much similar for any project, yeah, because you have to fetch the data from the request, and then you have to like do some authentication, and at the end you have authentication logic, and at the end you have to create the authenticated instance of authentication and put it into the context, yeah. And Spring Security noticed it. They noticed the setups will be pretty much similar, and that's why they created a sort of a template class, but it's not abstract, so it can be leveraged just by creating new instance of it. to reduce the amount of boilerplate code in the custom authentication mechanisms. So at minimum, you would have to specify only the things which are usually different from project to project. And first of them is authentication converter. And this one should specify how the authentication credentials are fetched from the request. So it receives HTTP request and it returns an authenticated instance of authentication. Yes, because your credentials can be in some header or they can be in the cookie. So you have to provide the implementation of authentication converter to know how to fetch the credentials from the request and how to create an authenticated authentication based on them. And then there is authentication manager, where you specify how to perform the actual rules of authentication logic, how to sort to say, convert unauthenticated authentication into authenticated authentication. Also, you have to specify success and failure handlers. It's not required, but yeah, it's usually unavoidable because the default implementations do the job that you usually wouldn't want to do. So there are two ways to leverage authentication filter. First of them is by extending it. So you can extend the authentication filter and then you can pass to the superclass implementation of authentication manager and also implementation of authentication converter, which looks sort of similar. Yeah, in my case, I'm fetching the data from the header, the credentials data from the headers, and I'm checking if this header is empty, I'm returning null. Otherwise, I'm stripping the prefix and I'm returning instance of unauthenticated authentication. Yeah, and the converter has to implement this authentication converter interface. And then in my filter implementation, I'm simply overriding set success handler and I'm setting failure handler as well. Also, I can instantiate authentication filter just by new keyword. Yeah, I can instantiate it, pass authentication manager and authentication converter there. And here I'm overriding the success handler and failure handler by setting my own implementation. So the success handler will be just no operation, and in the failure handler, I'm delegating to authentication entry point. Yeah, and now let's see a practical example how all of this can be leveraged. In this setup, we'll create the authentication mechanisms for the project, which should support two types of authentication for REST API. And the first one will be REST API authentication with JWT, for example, for web or mobile clients. Yeah. And the other one will be REST API authentication with API key, for example, to be leveraged by backend API, by backend app clients. And the implementation steps will be the following. We have to define two authentication implementations, each for a specific authentication mechanism. Then we define two authentication providers, also one for API key authentication mechanism and the other for JWT authentication mechanism. Then we define also filters, one for each specific mechanism, and the authentication filter would be leveraged to reduce the amount of boilerplate code. And each of the specific mechanism is set up as its own configurer to make it modular, and internally it leverages shared objects from HTTP security to fetch authentication manager from there. So let's move to the implementation. So it's this one. And first of all, let's take a look into authentication implementations. So I have two of them. I have API key authentication and JWT authentication. And this time I extended them from abstract class from HTTP security, which is called abstract authentication token. There is almost no difference whether to implement authentication interface or to extend this class, but this class provides you like some base level implementation of methods from authentication, yeah, it does implement this interface, and it provides some basic implementation, so it sort of leaves you with less code to implement. That's why I'm leveraging abstract authentication token here. Inside of this class, I have auth user. So in this setup, it just has a user ID roles and also some type of the user is not required to implement any interfaces. And I have GWT token because in this setup, the authentication will be leveraged both to transfer the credentials of authenticated request in case it will be authenticated authentication, or to transfer the credentials of yet unauthenticated request in case it will be unauthenticated authentication. So that's why we have GWT token here. And I have two creator methods. One of them is creating an unauthenticated instance of this authentication, and the other one is creating authenticated instance with auth user inside of that. And pretty much the same setup is for API key authentication. So it also extends abstract authentication token. It has auth user inside and it has API key. And there are two creator methods as well. So one of them is creating an authenticated instance, and the other one is creating authenticated one. And let's now take a look at the configurers of each specific authentication mechanism. So for GWT, I told configurers, so we have to start with configurers here. For the GWT configurer, I'm extending abstract HTTP configurer, and here I'm injecting the authentication provider and authentication converter, which will be leveraged in this setup. And I'm overriding two methods. In the init method, I'm registering the authentication provider. But let's take a look what's inside of the authentication provider. So it implements the authentication provider and has to override two methods. The supports method defines which type of authentication this authentication provider supports, and the authenticate method thus receives the authentication and it delegates to GWT service method. GWT service method resolves GWT token, which we've already seen in this talk, which either throws authentication exception or it returns our auth user with the details based on the content in the GWT token. And then in the configure method, we are fetching authentication manager from shared objects of HTTP security, and we are creating GWT authentication filter which is based on the authentication filter. It extends authentication filter, and we are passing here authentication manager. Also, we are passing GWT authentication converter, which implements authentication converter, and it fetches the token from the header, strips the prefix, and returns unauthenticated instance of authentication. So that's the setup for the GWT authentication mechanism, and for the API key authentication mechanism, the things are somewhat similar. So there are init and configure method. In the init method, we are registering authentication provider, which should convert unauthenticated authentication into authenticated authentication. And the logic of it is following. So it takes the credentials from the authentication and it checks if the key is contained within the collection of sort of known or allowed API keys. And this collection implemented simply as a property. So it's in application properties here. So it sort of checks if the authentication, if the client is present. If the client is not present, it throws an instance of authentication exception. And if the client is present, it constructs auth user and constructs authenticated instance of authentication. So moving back, to the configure method. In the configure method, we are fetching authentication manager because it was created due to registration of this authentication provider. And we are registering the filter. API key authentication filter is also based on authentication filter class. And we are passing authentication manager and API key authentication converter to its superclass, and we are also overriding success and failure handlers. And if you take a look in the converter, we are fetching the header from the request, and then we are creating an authenticated instance of the authentication. So that's pretty much it for this configurer as well. And the remaining thing here is security configuration itself. So the place when we are building security filter chain. And in order to leverage our configurers, I'm simply using this method, and I'm registering these configurers on HTTP security. This way they will be applied during the build phase. So at this time. And also there are some rules for authorization, and which are pretty much similar to what we've already seen in the previous examples. So moving on, the remaining setup which we yet have to discover is combination of entirely different security mechanisms within one project. Yeah. And the authentication requirements for this project will be the following. So for REST API, it will be pretty much what we had in the previous example, JWT and API key authentication mechanisms. But the other authentication requirement is to secure server-side rendered multi-page web application, like old style MVC web application, sort of pages and HTML forms, with allows login option. So it has to allow login via GitHub, and also form login, which has to allow login via login and password. Yeah. So let's take a look how it can be done. In order to achieve that, we have to register two security filter chains. One of them will be for REST API security, and the other one will be for our server-side rendered web application. So without further waiting, let's move to the code. So here I'm navigated to security config class, and it's just a regular class annotated with configuration. And here I'm exposing two bins of security filter chain. One of them for web application, for web UI application, yeah, and the other one for REST API. And for REST API, the setup is pretty well similar to what was in the previous example, except this security matcher. And the security matcher is ability to specify under which conditions this security filter chain should be applied to the request. And in this case, we are specifying that this security filter chain will be applied if the request URL starts with API. And in the other security filter chain, we are leveraging request, which also can be passed in this method. So you can imagine that you can set up all sorts of different rules if you want to, based on the data in the request. And in this case, we are checking that the request URI is not starts with API. And the security filter chains, when evaluated, they are evaluated in order. So it's not necessary to specify this condition here. We can use the order annotation to specify their order as well. So we can say that this one will be order 1 because it would check for the specific condition if the request URL starts from API, and this one will be then order 2. But I will instead explicitly specify that what are the conditions of applying this specific security filter chain. And on the security filter chain for web application, for web UI application, I'm leveraging two authentication mechanisms. First of them is form login, and I'm using user details customization point for this mechanism. And the other one is auth to login, which I'm enabling by using auth to login method. And you have to be aware that you have to add a specific dependency in order for this method to work, because the configurer it applies is coming from the other dependency. And for this authentication mechanism, we also have to register a specific customization point. We also can register specific customization point, which is auth to user service. It's sort of similar to user service. It does not have to be registered via HTTP security. It simply has to be declared as a bean, and then the logic which configures this setup within the appropriate configurer for this method would pick it up. So this is the implementation of auth to user service. I'm extending it from default implementation, which is default auth to user service, and similarly to have user service specifies details of fetching the user data by its username. This class specifies how the user data should be fetched from the identity provider. I don't want to implement all the low-level details of how the communication with the identity provider should happen. That's why I'm leveraging the method from default implementation, like this one. And then I can implement additional logic, and at the end, I'm creating the instance of auth user. And obviously, this method returns auth to user, so the auth user has to be compatible with this contract as well as user details contract. So in this example, auth user implements both of these interfaces, and obviously it does not have to implement any interfaces to be compatible with JWT and API key authentication mechanisms, because we haven't required to do so in our implementations. Yeah, and that's pretty much it for this setup. We have two security filter chains, each of them having two authentication mechanisms configured. Those security filter chains, each of them would have their own authentication providers registered. So due to user detail service method invocation, there will be the authentication provider. And also auth to login would register its own authentication provider. And we are registering two authentication provider implementations by our configurers. And one thing to note is that security filter chains do not share authentication manager. So authentication manager will be like local to each of the security filter chains. And now let's see what we've set up as a result of this project with different security setups. So we have four implementations of authentication. Two are custom ones: JWT authentication for JWT authentication mechanism and API key authentication for API key authentication mechanism. Then there are two from out-of-the-box mechanisms: auth to authentication token and username password authentication token. Then more than 5 configurers are applied, because almost everything that you invoke on HTTP security applies some sort of configurer. But there are 5 of them which we care for. 2 are custom: JWT authentication configurer for JWT mechanism and API key authentication configurer for API key mechanism. And there are 3 for out-of-the-box mechanisms: form login configurer applied because of invocation of form login, DAO authentication configurer applied because of invocation of user details service, and auth to login configurer applied because of invocation of auth to login. Then there are 5 filters, more than 5 filters, but 5 filters which we care of. There are a JWT authentication filter brought by JWT authentication configurer. There are API key authentication filter brought by API key authentication configurer. And then there are 3 for out-of-the-box mechanisms. There are actually more than 3, but 3 of them mentioned here. So 2 of them are brought by auth to login configurer, and 1 of them is brought by form login configurer. And 6 authentication providers are registered. So two are custom JWT authentication provider and API key authentication provider, and 3 of them are registered by the configurers of the out-of-the-box mechanisms. And there is also one more, which is dedicated for authenticating anonymous request when the anonymous authentication is present. And this one is called anonymous authentication provider, and even this one is set up by a dedicated configurer, which is called anonymous configurer. Auth user was made compatible with both user details and auth to user contracts. And 2 security filter chain beans were registering for specific security setups, and each of them has its own authentication manager. Well, now let's move to the conclusion. We went through lots of setups, lots of details. Now, as a recap, let's see what is the flow of the request in the application before it reaches your controllers through the Spring security. So first of all, the specific security filter chain is invoked, and which security filter chain will be invoked is based on the request matcher, and the security filter chain itself is invoked by some servlet filter, and which is delegating filter proxy, and then this filter delegates to a filter chain proxy, and filter chain proxy invokes one of the registered security filter chains based on the request matchers attached to them and based on the order. So only first of them which matches the request matcher will be invoked. And then within the authentication filter chain, the filters are evaluated one after the other, and their job either to create authenticated authentication and put it into security context holder, that is the job of authentication filters, or to perform authorization rules based on the authentication in the security context holder, or there are other filters like exception translation, attack protection, and so on. And in the custom mechanisms, in the out-of-the-box mechanism, there are also customization points. For example, there is authentication manager, which can be defined as a customization point to specify the details of how the authentication rules should happen. Also, there is authentication provider, which can be registered, and then the specific implementation of authentication manager will be leveraged under the hood, which is provider manager. And also, we can leverage user details service. We can provide either our own implementation, and then our auth user, the class which contains data about our authenticated user, has to implement user details interface, because that's the contract expected by DAO authentication provider. Or we can leverage some of the out-of-the-box mechanisms. And also there are authentication entry point and access denied handlers, which can be specified to define how we handle exceptions. But keep in mind, sequence of filters, the exception translation filter happens almost at the end of the chain. And if you define exception handling for out-of-the-box mechanisms, those are usually embedded within their filters. So after all of this, you might ask a question, which setup is actually recommended? And I would tell you that it actually depends. If you have simple custom auth, like in the first example, when you just have to secure your APIs by JWT authentication mechanism, well, then you just have to define your filter, and leveraging of authentication filter is recommended to reduce the amount of boilerplate. And then you have to also define your own implementation of authentication interface. And even though you can access the authentication implementations from the out-of-the-box mechanisms, it's highly recommended, if you don't leverage out-of-the-box mechanisms in your setup, to create your custom implementation instead. If you need to set up something like OAuth, OpenID Connect, Form Login, SAML, HTTP Basic, then use out-of-the-box configurers and provide your own implementation of customization points, either authentication manager or authentication provider or user details or something similar, like we've seen in the detail in the case of auth to user service. If you have combination of different authentication mechanisms, then you would have to specify a filter for each of them, create a dedicated authentication for each of them, and authentication providers for each of them, and defining custom configurers per each authentication mechanism is recommended. And if you have completely different or independent security setups in one project, it makes sense to create different security filter chain beans. And that's actually it for the basics. I hope it was useful for you, and now it's time for your questions.
Cool, thanks a lot for your presentation, and hope that both experienced and beginners found something useful and valuable in your presentation. Thanks a lot, Ihor. And let's move on to Q&A session. We have a lot of questions I see in the live stream chat. So I will go one by one, and and you will answer. So the first one from Stanislav Chmil. How would you implement multi-factor authentication in Spring Security-based application, ensuring minimal user friction?
Yeah, well, it actually depends. I haven't seen a configurer for MFA. Maybe there is some dependency you can find. To be honest, I haven't found it because it like requires some of the setup. Yeah. You can probably build your own authentication mechanism if you want to, but in such a case, if I would want to use MFA, I would probably rely on something cloud-based, maybe like Cognito, which supports such kind of the setups. And I would log in the user through the Cognito, and then I would leverage the public key for verifying the GWT tokens issued by Cognito. And I would like outload all this to this cloud service. And that's an example for AWS. Obviously, there are examples for the other clouds. If you necessarily want to do it in your application, you have to do some investigation. If you would need to build it from scratch, that's probably will be a bit of a nightmare, especially to support. So in general, I would recommend to keep as low logic on the application level in this case as possible, just validating the GWT tokens with public key and outload all the logic of MFA handling and so on to something like Cognito, if it's applicable for your setup, obviously.
Oh, thank you for your answer. Yeah, I would say you definitely fulfill this question. So the next one from Frankie De Jong. Question from him: how does Spring Security handle brute force attack prevention, and what additional measures can you take to enhance security? Interesting question.
Yeah, that's actually a good question. I'm not sure there is something in the default configurations for the brute force attacks, but you obviously on login can so when you log in the user, you can check for the API address or something like that, something to identify the user from where the user is coming, and you might just cache, for example. That would be something very simple. Just cache the user who is making a lot of attempts for some period of time, and then you would be able like to deny those attempts. That's if you want to leverage like login in your application, but usually in most of the cases you would rely on something like auth and something like that in real setups for real projects, for real world projects, and then obviously it's handled by the identity provider. But in case of if you want to handle a login on Spring Security side and not just the validation of the credentials for each request, then I would recommend keeping some sort of cache, maybe to the user IP, maybe to the other attributes, how the caller can be identified. Yes, thank you for your question.
Thank you. And the next one from Mike Miller. Have you ever tried to implement passwordless authentication using Spring Security?
Yeah, I haven't tried. Probably that's possible. I've tried some solution based on OTPs. It was not necessarily passwordless because it was just escalating of permissions. Was not hard though. But it depends how you want to deliver that OTP to the user. Yeah, obviously, if you want some push notifications and something like that, maybe you would like to consider some identity providers or cloud identity providers for that as well, because like integrating for pushing the notifications with OTP and something else which can be used in passwordless might not be that easy. But the logic would be like in your login endpoint, you pass something for the user for the passwordless, like OTP or whatever. Usually it's OTP in passwordless flow. And then you validate upon receiving it. Or you fully outload it to some identity provider, cloud, or some standalone service built on off-the-shelf software with available integrations within it. And then you simply leverage the token while like authenticating the request. Usually, like in my experience, logging in of the users is not happening in your application because you don't want to deal that much with keeping the hashes of the passwords and so on. So usually log in, you outlaw to some either cloud provider or trusted third party and so on. And then when the user receives the token, you actually validate this token using public key. Or you like, in the case, for example, with our code flow, you receive the token on the backend, you remember this token on the backend, like in OpenID Connect as well, it can be the case, because OpenID Connect is based on OAuth too. And you leverage this token if you want to connect via OAuth with some of the identity provider APIs or some of the resource service APIs, and you issue your own token to the user, your own GWT to the user, and the user comes with this GWT to you. So usually the login logic is not something which is very oftenly implemented within the system. Usually it's outlawed due to its complexity, because this question and the previous question were asking like how to set up complex login options. And the fact they are complex, they would make it hard for you to support. And that's the question to you, do you want to support it? Do you want to invest money into that? Do you really need to support such authentication mechanisms? Or you can leverage like trusted third parties or trusted identity providers for that. And on your application level, you would only implement verifications of the tokens. Either like the tokens from identity providers or the tokens that you issued based on the token from identity provider with your own details to the user. And upon each request, you are receiving this token because the user is sending it. But those were like two great questions. Thank you.
Thank you. And there are two comments connected to the previous questions that Spring Security does not provide built-in passwordless authentication. But as you mentioned, you can implement it using custom providers and not build it in our application. And also from the same user, Mike Miller, that I've just read that in the latest Spring Security 6.4, there is something like that, like integration of passwordless authentication.
Oh, that's great. Thank you. Good to know. But still, maybe for such complex authentication, for such complex login options, because authentication and login are two separate things. Login is to like providing the user with the credentials, based on his credentials, providing him with temporary credentials or something like that, token of such sort. And you can easily like outlaw it to the party which like handles all of this complexity. And then there is a point of authentication which you definitely has to implement in your system, either in your application or somewhere in your system on API gateway somewhere, just to intercept each request and fetch the data, fetch the credentials of user from there, and to understand who this user is and if the current action is performed. But
Thank you. And let's move to the next one. From Dmetrom Alyon. How would you implement rate limiting and abuse detection in a Spring Security-based authentication system?
So that's sort of related maybe to brute force attacks, because rate limiting itself not necessarily related to security. There are different ways to implement rate limiting. There are libraries which you can leverage, and they use some either token bucket or leaky token bucket, something like that. And that's not necessarily related to Spring Security. Mm-hmm. For abuse detection, that's like sort of a big topic. I'm also not sure Spring Security does implement at least some mechanism for that, but it has basic firewalling. It would check if the parameters in HTTP request are in the HTTP strict format and something like that. That's the basic firewalling it does by default, yeah. But something of a deeper abuse detection, that's a certainly bigger topic. You sometimes in scope of the system might want to outlaw it to some firewalls, like maybe cloud firewalls, as that's ideal place also to implement rate limiting. So if you, for example, set up AWS WAF in your infrastructure and something like that, infrastructure is actually ideal place to have rate limiting because it does not even reach your application level. And for the cloud providers, they don't charge you for the additional requests if their firewalls blocks them. So that's why it's ideal place to have rate limiting. But yeah, for the abuse detection, you might want to have something on the application side, especially if you like deep dive into something like zero trust, when you assume breach and something like that. But that's a bigger topic, and I'm not sure there is a built-in component of Spring Security. But as I mentioned, there are many things to Spring Security, many libraries of that, and there are many possible setups, so you maybe even find something like that. But if you know the basics, it would be really easy for you to navigate all of that.
Yeah, I agree. And we have 3 more questions. How do you mitigate auth2 code interception attacks when using the authorization code flow in the front-end backend system? From Valentin Boleslavsky.
Oh, that's a good question. How to mitigate code interception attacks? Well, actually, you have to configure your identity provider thoughtfully. Probably, it should allow only the trusted domains. It should allow only your domain. Nobody else could. In that case, it's not the part of Spring Security, definitely, but that's the part of probably some system level decision, system level design. But if you configure your auth identity provider or something like that in the way that it does not trust the other domains, so it means if inside of the parameters, inside of the auth protocol, if the user is redirected to identity provider and the identity provider sees the different domain in the redirect back URL, it would not redirect, but you have to configure it only to your own domain, to your own resource, and then all the redirects in the user's browser will be to your resource, and other ones will be blocked by the auth identity provider. And that's probably the only way, because interception can happen only in the browser, because it's user browser going to identity provider and then going back. And this going back with the code is the place where the interception might happen. And in this going back, you have to be ensured that identity provider would not redirect to some other URL based on the injection of some parameter and something like that. And that's probably the only thing you can do about it. As far as I can think about this question right now, to configure your auth identity provider properly to allow only your domain to be in the redirect URL.
I think each question can have its own presentation even, because they are complex ones. And
but those are interesting. Thank you for those questions. Some of them are more on the system design level, not definitely Spring Security, but
so next one from Rixton. How would you prevent privilege escalation in a microservice environment when multiple services rely on the same identity provider?
That's actually a good question. If you use auth, there is audience and scopes. So you can leverage you can provide the tokens specified to the specific audience with the specific scopes. And then in the place when you process this token, you check if the audience suits you. It's part of that authorization mechanism. You check if the audience suits you and if the scope suits you. And audience and scopes are part of the auth mechanism specifically for that. Actually, auth specification specifically for that.
Okay, and the last one for today from Mr. 7. In my application, we need very granular permission checks on the requested data. Do you think it's a good idea to secure class method using pre-authorize, pre-filter, etc. on each layer?
So you need very granular permission checks on requested data, class methods, and you mean class methods not only controller methods but service methods and so on?
Probably yes.
So you might use authorization rules within your service. I'm not sure how well it would be supported. It all depends on how you would implement that, how you would enforce that, and how you would make this sort of application design understandable and visible to everyone. Yeah, so everyone understands why it's done in this way and how you ensure the consistency throughout your setup. Yeah, but in general, you might use pre-authorize in your business logic, not only in your controllers, but just you have to develop the strategy on how to decide on consistency. And that's one thing. And the other thing, you have to be sure that all of invokers of your business logic, so to say, if you say about hexagonal architecture, all of the inbound adapters, they construct authentication, yeah, because your service might be involved. If your services are always invoked from REST API controllers and they always secured by filters and the authentication is created for each of them, then, well, there will be no problem because authentication always will be in the context. But when you have asynchronous processing within your application, you would have to think how to pass this authentication. And then if you process the events, something like that, and you would want to leverage the same methods within your business logic, you would see, hey, there is a pre-authorized annotation. And then you would have to like split those things. You would have the invoker with the pre-authorized annotation, and then you would have the business logic in the other place, which you invoke from the place where you don't have authentication in the context. So that's something you also have to take care of. If you would always have the authentication in the context whenever you invoke it, because it's easy when you put pre-authorized annotation on your controllers. Yeah, then obviously web controllers, REST controllers, they are always used within the web, yeah, and you would have authentication in the security context. But if you have pre-authorized throughout your business logic, then there is a question if there always be authentication. If you don't call this logic from the places where you sort of don't do the authentication because you process internal event or something like that, but you still do need to invoke that business logic. I'm not sure if I addressed your question correctly. Maybe if you have additional details about your question, you might add them now, but yeah.
I think it's a good answer, yeah. Yeah, and this is the last one for today, at least. Yeah, maybe someone will connect you in social media and continue discussion. And anyway, thank you for today's presentation, Ihor. Thanks a lot for your expertise and insightful presentation. Hope to see you next time with the next cool topic. And of course, also thank you everyone who joined today's event. And stay tuned, follow us in social media to do not miss next event, and take care. Bye-bye.
Yeah, thank you. Bye.